In the code that we've looked at so far in this class, most of the asynchronous code that we've used has used callback style programming. So basically when you call an asynchronous function, you pass in a callback, and then when the function completes, it calls the callback and passes in whatever value was calculated in the asynchronous function. So for example, to read a file, which can take a long time, you call the read file function and you pass in a callback, and then the callback handles the contents of the file when they're available. And the reason that Node does this is because JavaScript has a single thread execution model. So basically there's one thread that's executing everything in your program and everything in your environment. And if you tie up that thread with a process that takes a long time, then nothing else can happen. So you're starving execution from the rest of the program. By using this asynchronous model, the processes that take a long time, for example, reading from the disk, reading from network, reading from a database, those things can sort of happen in the background while the main thread of execution is free to work on the rest of your program. So this leads to code that's more efficient overall, but at the cost of some complexity when you're actually doing the programming. Because as you've seen with callback style, you end up with something that's called callback hell. So basically you call a function that takes a callback, and when that function is dead, it calls the callback. And inside the callback, you call another asynchronous process that calls another callback when it's done. And inside of that callback, there's another asynchronous function call that takes another callback and another callback. And each time you do that, the code gets deeper and deeper and deeper. And so writing that code and figuring out what's actually going on becomes more and more challenging. So what we're going to look at this week is some more recent programming developments, some technologies that simplify that kind of code a great deal. Makes it look more like regular synchronous code that you're probably used to working with in earlier programming classes, and less like that weird callback code that you've been writing this term so far. Now, one word of warning, a lot of this technology is fairly new and was developed in response to problems that programmers were having actually programming under the old callback style model that was in Node before. And specifically, there are some very important ways that the book is out of date. There have been some developments since the book was written that make the actual coding part of this different from what you're going to see in the book. The big concepts in the book are still all valid, but the actual syntax you're going to use for some of it has been simplified from what you're going to see in the book. And so I'm going to show you the most modern way of doing things. So in particular, the book talks about promises and it talks about asynchronous processing. The book uses some libraries, third-party libraries, to achieve those kinds of programming goals. But at this point, since about 2017, the JavaScript standard includes the final versions of both of those things. So JavaScript now includes a promise class that has all the functionality we need, so we don't need the Q third-party library. And it also includes async await, so we don't need any third-party support for that either. So let's start with a demo program that I've put together that we're going to look at this week. And it's also going to be the basis for your Lab 9 programming assignment. And right at the top of this lecture videos page where you're watching this video, there's a link to clone the WebChat repository. So I'm going to go ahead and open git bash. And I'm going to cd to somewhere convenient where I can download this repository. So cd c users mark downloads repos. Do I have a repos folder? Yes. And I don't have a web chat repository yet, so I'm going to git clone https github.com pcc-cis 195n /webchat.git. And then I'm going to cd into the web chat folder. And then for size, this folder does not include the node modules directory, but it does include package.json and package-lock.json. So what I can do as an easy way of jump-starting this is do npm install, and that will install all the libraries that are required by this project into the node modules folder. Okay, so it added 135 packets for 215 contributors. Really, I just included 3 modules. There's Express.js, which you've learned about already. There's MSSQL, which is a package for talking to Microsoft SQL Server. You may have seen that in the database module. And then there's also WebSockets, which we're going to use. And we're going to use those 3 technologies in order to create a web-based version of the chat server and client that we saw in lesson 5. So I've gone ahead and done the installation, and then if I do an ls now, you'll see that there's server.js here, and so I'm going to start by running server.js in Node. And I'm also going to go ahead and open that project. Actually, I'll do that after I demo it. So once the server is running, I can go to a browser and I can type http:// and then the IP address of the machine where the server is running, or I'm just running out on localhost, so I'll say localhost. And then there's a web server listening on port 3000, so I'm going to execute this command. And it should load up this page. Welcome to web chat. Type your nickname in the box below and press return to continue. So I'm Mark. And what it does is it shows me a log history of the 500 most recent chat messages. And this is preceded with some data from Internet Relay Chat on an Ubuntu support group, so that there was something realistic that you can look at. And let's see, Mark has left the chat, Bob has left the chat, Mark has joined the chat, and here I am. And then let's say on another machine, so I have a VNC viewer, I'm going to remote into a different machine. And then I'm going to open a browser here. If I know the IP address of the server that I was just looking at, so ipconfig. So this machine, my development machine, is running at this IP address on my local area net. So on this machine, which is a different machine with a different IP address, http:// 192.168.2.103 port 3000. That's the web server. And then here I'm going to be Bob. And so now I'm connected to the same chat server as Mark is, even though I'm on a different machine. So I can type, hello, Mark. And then if I switch back over to my current machine, I see that Bob joined the chat and he said, hello, Mark. I'll say, hello, Bob. So there's my message, and back to the other machine. And Bob sees the message from me. And then if Bob leaves, I see that Bob has left the chat. So pretty much the same functionality as we saw in Module 5, except this version is web-based. And let's actually look at the program now. So I'm going to go ahead and start up WebStorm. JetBrains WebStorm. Okay, and I'm going to go ahead and open the repository I just cloned. So that's in my downloads repos webchat. Okay, so here's the actual program. Let me adjust the window size. And then we're just going to do a quick overview here of the code. And then we'll look at it in more detail when we circle back at the end. And I have some tips and hints for you on Lab 9. So the web chat folder includes node modules. On the top level, it has a SQL file that's used to create a database. You won't need to use this for anything, but I included it anyhow. It's the SQL file that I use to actually create the database that you're using. It sets up a login called webchat and a database called webchat. And then there's a table. The webchat user has read and write permission on this post's table. And a post consists of an ID, which is basically just a sequence number, the name of the person who created the post, the type of the post can be a join, a leave, or an actual post of a message. The time represented as it's actually number of milliseconds since a date in, I think, 1970. And it's what JavaScript uses internally to represent a date and time. And then the actual content of the post itself in Unicode format. So if you haven't taken a SQL course yet, don't worry overly much because you don't actually need to know this, but if you do know SQL, it could be useful for you. And then we insert a whole bunch of records into that table. And then once the data actually exists, you can use it to execute queries. So for example, I'm going to go ahead and connect to the database here. And my account is Goodman. But I'm going to use the webchat login. So this is the permission you'll have when you connect to the database as well. So I'm connected as webchat. So I have read permission and write permission. So here's a command that's going to show me the 500 most recent chat messages. And what I have is some posts. And then here's a join with the user joining and some more posts. And here's a post with the same user leaving. And some more posts and some more joins and some more leaves and so on. So 500 most recent chat messages. So that's what we use to generate the contents of this chat pane preceded with data. And then whenever somebody leaves or joins or adds a message, that new content gets appended to the table as well. So it's persistent, and anytime somebody comes in, they'll see it, at least until I reset the database by re-executing that script. So that's the database. And then we access the database using the code in this database.js file, where we define a class called database. And it's got a constructor. And what the constructor does is it basically initializes a connection. And that's an asynchronous function when you initialize the connection. We'll get into the details of how that actually works a little later on. But there's a method called fetch history. And here's an asynchronous await version of fetch history, which we'll learn about. Basically, it executes this query and then returns the set of rows that it got back from that. There's also a method called add message that reuses the same connection, and it executes an insert statement to store this message into the database, the posts table. And finally, there's a close method that gets called at the end that frees up the database connection. So pretty simple here. And then there's also this server code. And I'm going to start at the bottom and work my way up. There's not actually that much code here. I create an Express web server. That's pretty simple. All it includes is the Express static, so that it serves static pages out of this public folder right here. And then it listens on port 3000. And then there's also, this is going to be new to you, this code here, which creates a WebSocket server running on port 3001. So there's actually two separate servers in server.js. The first running on 3000 is a regular web server, and the second running on 3001 is a WebSocket server. And WebSocket interface lets us do the same kind of thing as we were doing in lesson 5 when we created a socket connection to the backend web server so that we could exchange messages about people joining and leaving the chat and posting messages to the chat. So same idea, it's just implemented on top of the web protocol. There are ways of using WebSocket that can reuse the WebSocket, the socket connection that you create when you attach to a web server. You can take the connection that you get when something attaches here and upgrade it to a WebSocket connection, which is bidirectional and can be used to send multiple messages. But the easiest thing to do is just what I've done here and have two separate servers, one running a web server using Express and the other using running a WebSocket server that uses this code here. So here's the actual code for my WebSocket server, and it starts there and it ends here. It's all based on event emitter programming model. So I'm listening for a connection event on my web server, WebSocket server, and when I get a connection event, then that's going to call this callback function, which takes a WebSocket and also a request stream. The first thing I do is send the log history to the WebSocket, and that involves making a database connection, fetching the contents of the most recent posts to the database. And then after I've sent the history, I start listening for messages. And when I get a message on the WebSocket, it's going to be either a join, a leave, or a post. I convert that into a JavaScript object. It's going to be a message in JSON format, just like before. I add the current time on the server, write that message to the console, and then I convert the message back into a JSON string because it has a date on it now. I add that record, actually add the message to the database by calling the add message method on the database object. And then for each client who is currently attached to my WebSocket server, I can send that message to each of those clients. So that's a little easier than what we had in lesson 5. And that's basically it. I'm listening for a close event on the socket, but I'm not actually doing anything, so I could probably get rid of this right now. I also log the IP to the console every time somebody connects to the server. So if I look at my, where did I run that? Yeah, so I ran that from git bash. So I connected to localhost, and it shows me the IPv6 address for localhost. And I also made a remote connection from my other machine. So I connected from 192.168.2.33 to this machine, which is 192.168 to 103. And then the messages and the leaves and joins. So that's basically all the code there is. We're going to look at this in a lot more detail a little later after I've started talking about some stuff. But there's not a whole lot of code here. In terms of the public folder, the stuff that actually gets served to the client, the main thing that gets served is this index.html file. And it includes a style sheet in client.css and some JavaScript code in client.js. After the page is loaded, it calls the init function in client.js. The HTML includes a all of this code here is basically that little pop-up that asks you to type your name, and the rest of it is basically the chat pane and the input box underneath the chat pane where you type your messages. So let's look at this again. So here's the chat pane. Here's the input box where you type the messages. And if I reload, I can see this dialog box where I type my name. And then the JavaScript includes this input method. And basically, when you start this thing up, it focuses on the input box where you type your name, and it attaches a key up event listener to that input box. This is just running in the browser now. So when the user starts typing, that causes these event callbacks, event handler callbacks to get called every time the user has a key up event. And it's looking for either the enter key or the number pad entered to be pressed. When it gets that, it goes ahead and hides that input dialog and also the background screen that it's sitting on. And then it calls the name entered function along with the user's name. So name entered has basically some logic to these are all formatting things, how to format a date so it looks good on the screen, how to convert an arbitrary string into something that's safe to actually display as HTML format without having special characters interpreted as HTML. There's an event listener for resizing the window. So if I resize this, it still looks nice and it still keeps me at the bottom of the screen. There's a WebSocket connection on this side. So this is the browser code that connects to the WebSocket server running on my backend. So whatever the window location.hostname is that I specify in the URL, it's going to open a WebSocket connection back to that machine on port 3001, and that's what socket's going to be. And then socket uses the event emitter style to handle an open event. So when I open a connection, or when the connection is open, in the callback to that, I can go ahead and start processing message events. So now that I'm open, I'm going to start getting message events, and every time I get a message event, it's going to be, the type of the message will be a post, a join, or a leave. I do some simple formatting, and then there's also an end event, which I'll talk about in a second. But basically, I format up a message This code does a little bit of lifting in order to, you'll notice that like if I type something, that's in a new message block with Mark because Mark is not the same as system. But if I type again, that's going to be in the same block because it knows that both messages were authored by Mark, and this message was less than an hour, sent less than an hour from this message. So it attempts to group these things together instead of giving you a new header line each time. And that's what all this logic is doing. It's basically figuring out whether it should create a new header line here or whether it should just add the message to the previous block of messages. And then this end socket, this end message, that actually happens if you look at the server side. When it sends the history, you'll notice that the first thing it does is it fetches the history from the database, and that gives it a record set, which is an array of messages. Then for each message that it got out of the database, it sends that on the WebSocket. When it's done all of those, then it sends an end message to say that it's done sending the history. So it's that end message on the client side that lets me know that the history is done. And when the history is done, I go ahead and I send the join message. And I also dump all of the HTML that I've buffered up so far from the history. That's when I actually display it in the chat pane and then scroll down to the bottom. And then the only other thing we really have here is some additional event handlers. So I'm looking for the window to close or to get reloaded. And before I unload the contents of the window, that's when I send the leave message to the web server so that the web server knows that I'm not there anymore. And I also have an event listener key up on line input. And that's what reads when I type something in and hit return. So here too, I'm looking for either an enter or numpad enter on the input line. When I get that, I go ahead and send a post message to the web server and clear out the value on the input line input box. So that's all the code. So some parts of this we haven't seen yet. For example, this then stuff and read and fetch history. You see something is async and await. And like here's a promise version supposedly, and it's returning something .then .catch. And it doesn't use callbacks, right? So when it's doing something that takes a long time, like this connection.query, in the past you might have seen something that looked like connection.query, and then you have a query string, and then after that you have a callback function that either gets an error or gets the record set when it's done doing the retrieval, and then processes that inside of the callback, and maybe inside of there is another callback, and so on. Here what we're doing instead is we're calling a then method on whatever this.pool returns. This is actually going to be a promise. So promise.then do something, and then .then do something else, and then .catch to handle any errors. So we'll be learning about both of those things this week.